So this one is called modular fingerprinting and deep learning for interlocation, and it's a new training approach. Okay, this work is from Darwin Quezada-Gaibor, a former PhD student that then moved to a company and now is back as postdoc at university. So he tastes both industrial and academia. So this is the main layout of the presentation with, introduction, related work, algorithm, experiment, results, conclusions, and a main message. Predicting the future is not magic. It's artificial intelligence. Okay, so why this work? Because we have realized that there has been an increase of use of deep learning and machine learning for indoor location, in particular to fingerprinting problems, and that it can be used to extract meaningful information from the data sets. Sometimes we have a data set that is providing whatever accuracy, but new machine learning technique or a different machine learning technique can exploit some features to improve the accuracy. So we are getting accurate solutions. The accuracy is limited to the technology. Obviously, we are not going to get 0 centimeter errors with Wi-Fi fingerprinting. It's around 4 or 5 meters because of the inaccuracies of the RSS, the received signal measurements, but it's good enough. And the challenges of indoor environments are different here, in the auditorium or in the guest house. The devices are, and the signals are completely different in those scenarios. So the idea of this work is, what about if we use fingerprint aggregation? So that instead of having one model fitting all, we have different models fitting different regions of our system, of our operational area. That can lead to 3 different outputs. We can reduce the radio map, the data set for a particular model. We can generate a specific well-trained models for this room, for the next room, or for this floor, and reduce the positioning error because the systems will be more specialized in a region. There are 3 papers that we identified in the literature. The first one is from Saha et al. 10 years ago. It already grouped similar fingerprints. Then in 2022, Vladimir Villas-Apparent provided a survey on machine learning and interlocation based on fingerprinting, identifying that most of the solutions were based on machine learning. And finally, Panja et al. This year ago, they provided an autoencoder plus the convolutional neural network for reducing the dimensionality of the problem. Instead of working with all the set of Wi-Fi IPs that are available in the environment, just to reduce to the most significant or the more relevant ones. Good. So this is a layout of the proposed method. I saw before, I was seeing before in my, better in my computer, but it's a little bit sliced. But the key is that you have the inputs, which are the intensities from the different Wi-Fi access points. And instead of having one unique model, we have a model that disregard by AP. So if the AP that is the most strongest one is, well, there is no one AP here, is that one in the corner, then I will use a radio map for that AP. I'm not going to use one radio map that is for the guest house, which is far away. I'm going to use a radio map that will be tailored for that AP. And here you have the main schematics. So the first key is to group similar fingerprints. How to group the similar fingerprints? By the strongest IP. So if the strongest IP is that one, all fingerprints will be grouped to that IP. Then there is some data processing, like removing the features with no data. If there are IPs that are never the strongest one, we remove them. Okay, and then we train the different models. And finally, we need to save them. Okay. On the online phase, when you want to get your location, there are two parts. The first one is the data preparation, which is to collect the data. And then with the data you collected, determine which model to use. How to select the best model is to look at the best APs, the APs with the strongest RSS, with the strongest signal. And I'm not talking about one, I'm talking about N or multiple strongest APs, and then to do the inference with the models. Here you have a basic description of the algorithm. It's on the paper, and I will be glad to explain you later if you needed some details. And here you have the same, the algorithm for the inference. It's not magic, it's simple. It's something that you don't need rocket science, but I will be glad to explain you later if needed. So we ran some experiments on a MacBook Pro M1, not that one, it was Darwin's computer, using Python 3.9 and TensorFlow 2.12. It's important because we are providing what are the elements used to do the experiments in case you want to reproduce them. And we used 3 public data sets, the Ookindor log I mentioned before, and 2 others that were collected, one in Tampere in Finland, and the other I think it was collected in Asia. I think it's in Sydney, in Australia, sorry. I was mixing 2 data sets. It's in Sydney, that one. And we compare our method to 4 methods in the literature. It's not that we are just providing our results compared to a baseline. We are providing results based on the state of the art. So basically, we used 2 metrics, which is the 2D error, the mean 2D error for location, and the 95th percentile. And this is CNN log, which is a state-of-the-art convolutional neural network for fingerprinting, before and after applying our approach of modular training. And you can see that, for instance, for the UGI1 dataset, we decreased the error from 18 meters to 8 meters. It's almost more than 50% less. And then for the Tampere University of Technology dataset, we reduced from 17 meters, around 17 meters, to 11 meters. It's also a good, very good result. And finally, for the dataset collected in Sydney, we got a slightly worse result. It's what I said before, replicability. To be honest, in those cases, we want to come up with an algorithm. 1 dataset is not enough. We need more. And probably 3 is not even the best number. We should provide, let's say, a benchmark with 50, 60, 100 datasets, as usually done in machine learning community. If we limit our experiments to just 1 dataset, the results and conclusions will be slanted to those datasets. Good. Yeah, this is what I was telling before, with 53% improvement, 53% and almost 20% of decrease of increase of the error. And on a graphical form, just to show you the floor hit rate, we got almost similar results. So for floor detection rate is just that the system was able to say you are on floor 1, floor 2, or floor 3. And in both cases, with and without our approach, the results were similar. A bit worse with the modular approach. But this is not a problem, because if you have a good classifier for the detecting the floor, then you can use a model for regression tailored to that solution. Good. We also compare to other state-of-the-art algorithms like AACNN, CCNlog, and CCPOS. And we have mixed feelings, because for the ANCNN, the results are a bit better than with our approach. But for the TUT3, our results still are, are significantly worse. But still, there are different approaches. And moreover, with the ANCNN, we are not applying any modular approach. Maybe if we apply the modular approach to those methods, to AECNN, the CCNlog, or the CCPOS, maybe we can improve those results, as we did with the CNNlog. So as conclusion, the training models tailored to specific parts of the operational area can improve the results. Makes sense. Also, they led to less complex models, less or lower training timing, And the benefits are that the results are similar and even much better. Only in one case we got worse results. Another cons, this model introduced a new hyperparameter, the number of APs in the operational phase you take to select which model to use. In some cases, it has been 3, in others have been 4. It's another level of complexity. And for classification models, the training with the entire data set with no modular approach is much better because the classification task is simpler. You are on floor 0, 1, 2, 3. So maybe we need to move to another simpler approach for that task. As before, this project has been funded by the Generalitat Valenciana. No need, this time don't need. Here you have the bibliography and if you have any questions, I will be glad to answer them. By the way, divide and conquer. And if you want to get my contact details around the QR code.